Hi all, today we can see the modeling of electromechanical systems. Electromechanical system means in that particular system there will be electrical system and also mechanical system. So DC servo motor is an example for an electromechanical system. And what do you mean by servo or servo mechanism? Servo mechanism or servo. It is a feedback control system in which the controlled variable is mechanical position or its time derivatives. Time derivatives of position. They are called servo motors. Servo is a feedback control system in which the controlled variable is mechanical position or time derivatives of position. The speed of the motors can be controlled by varying the armature voltage. These are called armature voltage controlled DC servo motors. DC motors can be controlled by either controlling the armature voltage or controlling the field current. So there are two types: armature controlled DC servo motor and field controlled DC servo motor. Now we can find the transfer function of armature controlled DC servo motor, that is modeling. So this is the system: armature controlled DC motor, armature control. So we are varying the armature voltage, therefore field current is constant. And RA, LA are the armature resistance and inductance, and EA is the applied voltage, EB is the back EMF. And for the mechanical system, the coefficients are B0, J, and theta is the angular displacement. Theta is the angular displacement. So servo means one of the control variable is angular position. So angular displacement theta. Now we all know torque produced by the motor. See, it is proportional to phi into Ia. Or we can write this as the torque produced is proportional to IF Ia because flux is proportional to field current. Flux is produced due to field current. Therefore, we can write this equation like this. And now we are assuming that this field current is constant. We are varying the armature voltage. Therefore, Tm is equal to, we can write this as Tm is equal to KTIA, where KT is the motor torque constant. So one equation, Tm is equal to KTIA, and back EMF EB is equal to KB into d theta by dt. The EMF produced, that is due to the rotation. So, and KB is the back EMF constant. So we can write EB is equal to KB into d theta by dt. Now write the differential equation. Our aim is to find the transfer function of this electromechanical system or armature controlled DC servo motor. That means here the input is armature voltage EA and theta is the output variable, control variable theta, speed control. So transfer function is theta of S divided by EA of S. So our aim is to find the transfer function theta of S by EA of S. For that, what we have to do is we have to take the differential equation representing the electrical system, that is RAIA plus LA DIA by dt plus EB is equal to EA. We have to consider this back EMF also. It is opposite to the applied voltage. So RAIA plus LA DIA by dt plus EB is equal to EA. And the mathematical model of the mechanical system is given by J into d square theta by dt square plus B0 d theta by dt. That's equal to Tm, torque produced. That is equal to KTIA from the previous slide. Tm is equal to KTIA. Here J and B0 is given. J d square theta by dt square plus B0 d theta by dt is equal to Tm is equal to KT into Ia. Now take the Laplace transform in order to find theta of S by EA of S. So take the Laplace transform of this equation. T of s is equal to kt ia of s, EBS is equal to kbs theta of s, because d theta by dt. So apply differentiation theorem. So s theta s. Similarly, for this equation, Ra plus SLA, because dIA by dt, we have to apply differentiation theorem. Therefore, S. That is why S is here. IA of S plus EB of S is equal to EA of S. We can write IA of S is equal to EA of S minus EB of S by RA plus SLA, A suffix. Okay. Now, this Laplace transform of this equation, j square, again d square theta by dt square, therefore j s square, applying differentiation theorem, plus b0 s d theta into theta of s taken outside, equal to t of s is equal to kt ia of s. Now, the block diagram. These are the same equations in the previous slide. So, the first equation is IA of S is equal to EA of S minus EBS divided by RA plus SLA. So, EA of S minus EB of S. Therefore, there will be a summing point, and the applied voltage is EA of S. And IA of S is equal to EA of S minus EB of S into 1 by RA plus SLA. So, draw the block, give the transfer function for this block like this. 1 divided by RA plus LIS in order to get IA of S is equal to this expression. Similarly, TS is equal to KT IAS. TS is equal to KT IAS. So that draw the block diagram like that. Then J square plus P0 S into theta of S equal to T of S. So theta of S is equal to Ts into 1 by J square plus B0 of S. So the transformation for this block will be like this. And last, EB of S is equal to KBS theta of S. So EB of S is equal to KB of S into theta of S. So these are the blocks. Then combine all these blocks. Input voltage is EA of S. So summing point is here. Output is theta of S. Here IA of S. Then connect this block here and this block here. So you will get the block diagram like this. Therefore, theta of S equal to, this is cascaded connection. So theta of S is equal to KT. You will get KT is theta of S equal to KT into EA of S minus EBS divided by RA plus SLA into J square plus B0S, and write EB of S is equal to KBS theta of S. Then solving for theta of S, you will get like this expression like this. Therefore, the transfer function is theta of S by EA of S. That's equal to KT divided by S into RA plus SLA into JS plus B0 plus KT KB. Now, usually the inductance of the armature winding is small, and hence we can neglect that. Therefore, this term will, we can neglect this term. Therefore, transfer function theta of S divided by E of S is equal to KT divided by RA. This term equal to 0. So RA. So take KT by RA. So JS plus B0 plus KT KB by RA. Now write it as KT by RA divided by S into JS plus B, where B is equal to B0 plus KT KB by RA. Similarly, transfer function of a field controlled DC servo motor. Here, field current is varying and armature current is kept constant. So the equation, uh, according to Kirchhoff's voltage law for the electrical system, the equation is RF IF plus LF DIF by dt is equal to EF for the electrical system. For the mechanical system, it is J into d square theta by dt square plus B0 d theta by dt is equal to torque is equal to KT into IF. Now take the Laplace transform of these two equations. R of RF plus IF of S plus LFS into IF of S. S apply differentiation there equal to EF of S. Similarly, take the Laplace transform of all equations. Then draw the block diagram. Input is field voltage EF of S and output is theta of S. So this EF of S into 1 by RF plus SLF, that's equal to IF of S. And from this expression we will get T of S is equal to KT into IF of S. Similarly, this T of S and theta of S relation 1 by J square plus B0 S. So this is the block diagram. Now combine, cascaded. So take the product and you will get the expression like this. The transfer function of a field control DC servo motor is KT divided by S into RF plus SLF into JS plus B0. Now take RF outside from this expression and here take B0. So in the numerator it will become KT divided by RF B0 divided by S into J by B0 plus 1 and LF by RF plus 1. So this is the expression, and this is also equal to Km divided by S into tau ms plus 1 into tau Fs plus 1, where Km is equal to this term Kt divided by Rf plus Rf B0. Tau m is equal to J by B0. Tau F is equal to Lf by Rf. So this is the transfer function of a field controlled DC servo motor. Thank you.